हरि करना।
So now you may ask a question that why are you spending this much of time in understanding and making us understanding confidence interval? Because does it have any relation with the data science or data scientists? Because normally in data science they don't give much importance to confidence interval and all. They'll just data science for people means machine learning algorithms and get into the machine learning algorithm, copy machine learning algorithm, put it and then do some exploratory data analysis and give some output and that's it, there ends the matter. No, not at all. I will show you what it is. So now let's look into the importance of confidence intervals for data scientists. So the first one is communicating results. This is what the most important aspect. This is damn important, damn. So confidence intervals can help communicate the uncertainty associated with estimates or predictions to stakeholders. For example, a data scientist can report a confidence interval around a predicted sales figure to indicate the range of plausible values. So what will we do? Let's look into the basically the it's very important tool. A confidence interval is very important tool to understand. Let me put it here. Why does it matter to me? So very important aspect of any model is performance of that model. So how do you check the performance of the model? So performance of the model. So let's look into the performance of the model. So normally a data scientist can use a confidence interval to assess the performance of their models by comparing the model predictions to the actual outcomes of the target variable. So confidence intervals can provide a range of values that the true outcome of the target variable is likely to fall within, given a certain level of confidence. So some of the metrics, first we will look into the metrics and how can we use them to understand and to give the results, to explain about the performance of the model in a better way. How can we leverage the confidence interval to explain about the performance of our model in a better way, which makes the better sense. So one performance model, such one performance technique that we use is mean squared error. This is called MSE. So this measures the average squared difference between predicted the actual values. So confidence intervals can be used to identify whether the model's prediction fall within a certain range of actual values or not. Okay, so let me show you that mean square error. So now a common metric for regression model. This is specifically used for the regression model. In regression model, MSE measures the average squared difference between the predicted and actual values. To obtain a confidence interval for MSE, one can use a resampling techniques such as bootstrapping or cross validation. For example, for example, 95% confidence interval for MSE of a linear regression model with 50 test instances might be. Let's take the value 0.14 to 0.42. This will give you more value than just simply giving a one value. we are not sure whether that's actual value or not. So this 0.14 to 0.42 indicates that we are 95% confidence that the true MSE of the model lies between 0.14 and 0.42, which makes more sense than simply just giving some random value in between 0.14 and 0.42, saying 0.35. So similarly, we have other accuracy measurement techniques, performance measurement techniques such as accuracy. You got the accuracy. Then we got the precision. Then we got the F1 score. Then finally we got the AUC and ROC. Okay. So let's look into the one by one. So first one we have seen. Second one is accuracy. This metric measures how often the model correctly predicts the outcome. So it's the ratio of the number of correct predictions to the number of to the total number of predictions. In this, if we use common, this is a common metric. Let me go up for here. Yeah, this is a common metric used for classification models. Classification models. Okay. So accuracy is the proportion of correctly classified instances out of the total instances. To obtain a confidence interval for accuracy, one can bootstrapping. For example, when we say 95% confidence interval for the accuracy of binary classification model with 100 test instances might be, let's take 0.82 to 0.96. So which means we are 95% confident that the true accuracy of the model lies between 0.82 and 0.96. That's it. There ends the matter. Next. So next we will look into the another method, which is precision. So precision is nothing but precision is a measurement. Precision is a technique which is used to say how often the model is correct when it predicts a positive outcome. It's the ratio of true positives to the sum of true positives and false positives. Then another one we have for us is area under curve, AUC here, area under the curve. So common metric for binary classification. This one is for the binary classification. So here also AUC measures the ability of the model to distinguish between the positive and negative instances. So to obtain a confidence interval for AUC, one can use bootstrapping. For example, 95% confidence interval for the AUC of a binary classification model with 200 test instances might be, let me say the value of 0. Let me say the value 0.82 to 0.96. This means this indicates that we are 95% confidence that the true area under the curve of the model lies between 0.8 and 0.96, and similarly applicable to the F1 score when we say 95% of confidence, and if you give the bracket or interval, we say that we are 95% confidence that the true F1 score of the model lies between 0.68 and 0.86. Just that's just for an example. Okay. So similarly, we have another benefits for data scientists. Second one is for the comparing the groups. For comparing the groups, confidence interval can be used to compare the means or proportion of two groups. if the confidence intervals around the two estimates do not overlap. This suggests that the difference between the two groups is statistically significant. Similarly, it can be used for the decision making. Confidence intervals can be used to guide decision making. So, for example, if the confidence interval around the expected return on investment for a project is wide and includes the negative values, this may suggest that the project is too risky and should not be pursued. And the final one, that is sample size determination. So confidence intervals can also be used to determine the necessary sample size for a study. A narrower confidence interval requires a larger sample size, and wider confidence interval can be obtained with a smaller sample size. And one more a technique or one more unit that's used to measure the performance, that's r squared. So this measures the proportion of variance in the target variable that's explained by the model. So confidence intervals can be used to identify whether the model's R squared value falls within a certain range or not. So with this, in general, confidence intervals are a useful tool for assessing the uncertainty associated with estimates or projections, and which can hugely help data scientists make more informed decisions based on their data.